it says worksheet number 1, so I guess it must be unit 1. Okay, so we're going to solve each of these ones by graphing. Now, I think I've done examples of a few of these before. So I'm going to skip number 1 and number 2. An enterprising student could maybe go and, you know, find where I have done those previously. Tell you what, I'm going to do numbers 3 and 4 here today on this worksheet. So, number 3, we have 2x minus 2y equals negative 2. And we have x equals 4. Now, one of the reasons I wanted to do this one on the sheet, or on stream rather, was to show you partly what comes up when we have these strange cases like this, x equals 4. What does that even mean, x equals 4? I'm going to do it in green over here. Imagine I wrote that in green first. See if it comes through on the screen very well. Still here for now? Hi, well, good morning. Morning, Albert and Esther. Glad to have you with me. Gonna go over a few of these ones first. Just 2 of these, I think. And then I'll get to, Esther, the ones that you mentioned. Okay, so y and x, label those axes, right? So now x equals 4, what does that mean? Well, x equals 4 are all the points where the x coordinate is 4, right? So that's the same as, say, 4, 0, so 1, 2, 3, 4. So say 4, 0 is right here, 4, 1, say right here, 4, 2, say right here, 4, minus 1. So x equals 4 is actually a rare case in these sort of examples where it's a vertical line. You're not going to see vertical lines very often. The only time you're going to get a vertical one is when it's x equals 4, right? Oh, I should have drawn this in green too. So that was the whole point, wasn't it? The whole point was to make that one green so it's color code. Anyway, it's tough to see on there. But this is x equals 4, right? It is worth knowing that this one is not a function, right? This is how you will graph it. You will graph it as a straight line. But x equals 4 is not a function because it fails the vertical line test, right? Which means it has some points that are above or below, directly above and directly below other points. Rather, is not a function because there's multiple y values for given x value. Right? Now, this is not something that we need to know for this question specifically because it wasn't asking about this directly. But you know, x equals 4 is a vertical line, which means it is not a function. I'm going to go back to the other one. 2x minus 2y equals negative 2. There's lots and lots of different ways that we can graph these ones. Now, I do recommend rearranging this to get y by itself. And if y is totally by itself, the form that we have then is slope-intercept form. The slope-intercept form is one of the easiest ones to graph. Right? So we're left with, if I move this 2y over here and this negative 2 over here, we'll be left with 2x plus 2 equals 2y. And unsurprisingly now, if I divide every term by 2, we're going to get x plus 1 equals y. Right? And that's super easy. So we now know that our slope equals 1, because if there's nothing there in front of the x, we take that to be a 1. And this is a plus 1, so we know that the y-intercept equals 1 as well. Right? So now I'm going to go up 1, and this is going to be my y-intercept. Then I'm going to go right 1 and up another 1. That's another point. Right 1 and up another 1. It's another point. So now I'm just going to go ahead and draw this. and I'll label it x plus 1 equals y, right? So from on here now, I really can't, because I've drawn this totally freehand, like, well, without using grad paper, I can't really say what exact point this is, but when you graph it um, on your sheet, or if you don't have a printed sheet, I can't remember. I think this one's for Betty Ann. Can't remember, Betty Ann, if you have a printed copy of this course or not. But if you do, you can just draw it right on there. If not, um, if you don't have any graph paper or the stuff printed off, you might have to not solve by graphing this way. Although you can head on over and solve by graphing another way, which of course is on over here in our good friend Desmos, right? You can now see if they'll do x equals 4, right? They're actually not going to do that. Oh, no, they did do that one. There we go. X equals 4 right there. Vertical line. We got that one. And then we got x plus 1 equals y. There we go. Right? And now from our pal over here, we can slide on this way. Here we go. And then we get 4, 5. Right? So we see that the point of intersection, or after we've graphed these all, we see the POI, or the point of intersection, is going to be 4, comma 5. Right? We could also very, very quickly and very easily solve this one via substitution as well. So Betty Ann, say this was a situation where you had to do one like this, but there was no way at all that you could graph it. Like you don't have access to a Desmos, or you don't have graph paper or something like that, and you want to test these by substitution. This is already practically done by substitution, right? Because we already know that x is equal to 4. So we can just plug that in here. 4 plus 1 equals y, 5 equals y. Unsurprisingly, 5 is the y coordinate of the intersection here, right? So this one's kind of already done in terms of when we're talking about solving via substitution. Let me carry on then, and I'm going to go down to question 4, which is on the same page. I will try to graph it on this same one as well. I'll use 2 different colors this time, because last time I kind of used black and blue, because I meant to use green, but I didn't actually end up using it. So I'll just write this one over in black so it's obvious that this was the first question. Then I'll use red and green for this next one. Right? Red, green. It's good. Some good good stuff. You see my title? See my title there, which is like there? Right? I was considering putting in the Latin phrase for the Possum Lodge. Quando omni fluncus mortai. Sit down. Right? But that's when all else fails, play dead. I mean, it's a reasonable moniker, right? It's not a moniker. It's good philosophy, I suppose. Good life philosophy. Maybe it's a bit grim for right this second though. But the message that follows is pretty wholesome, right? We got that one right there. Anyway, let's flip on back. Where am I? Right, at home, of course. 2x minus 3y equals negative 6. So now let's rearrange this one into slope-intercept form, right? You could use a lot of different forms. I just find slope-intercept form to be by far the easiest one for graphing. So I'm going to swap, move this 6 over here, move this 3y over here. This is not an algebra course, so I'm not going to like super belabor the algebra rearranging. We'll have 2 over 3x plus 2 equals y. Starting to think I did this exact one before. I might have, but it'll be a fresh reminder for you. And then the next one is 4x minus 6y equals 18. Right? Now this 18 is going to move over. It's going to be 4x minus 18, and this is going to be equals 6y. So we're going to have 4 over 6x minus 3 equals y, over 2 over 3x minus 3 equals y. And yes, I do recall now that I did this exact one before. Okay. So I'm not actually going to belabor the point on this guy so much. But Betty Ann, you did also ask about how you go ahead and graph them. So I will remind you of how you graph these guys, right? There now in a second once I check and see what this noise was. Okay, so for this one here, 2 over 3x minus 3, we're going to go 1, 2, 3 down, and this is where it starts, right? And now we know that our slope is our rise over our run, so it's going to go up 2 when it goes to the right 3. 1, 2, 3. So it's going to be about here, the way I've got these ones drawn. Now, obviously, this is this is a super scuffed uh, scale here, so you know, not super accurate, but this is going to be 2 over 3x minus 3 equals y. And then I'll do the next one in green. So that'll be plus 2. So start from up here. Then also still go 1, 2 up and 1, 2, 3 to the right. So that's going to look like this. And here, yeah, I haven't drawn them super accurately. Excuse me, because you can see them kind of converging there, and they should ideally be not converging at all, right? That's going to be 2 over 3x plus 2 equals y. Okay, yeah, these ones are going to have no point of intersection, right? So these ones here are going to be parallel. Right? We've seen these ones before. This was an edge case that I think I went over the last time I was covering this unit. Yeah, I think I actually did these exact ones. But as you see here, the parallel lines, they have no point of intersection. But what you asked about specifically was how to graph them based on what you do. So the answer for how you graph them is, I'll put it over here, graphing. All right, so I was asked basically how you graph these guys. Well, the way you graph them is first you put them into y equals mx plus b form. Then step 2, m equals slope, b equals the y-intercept. Okay, so that was the first topic, graphing systems of equations. Okay, so I'm going to now take a look over at these ones with central tendency. So Esther, I believe you were asking for page 90. Okay, now I'm not going to do, I am absolutely not going to do all of what's here on page 90. I'll do part of question, I'll do, say, one or maybe two of the question one ones, right? But these are good ones for you to be practicing yourself as well, right? Because these are sort of good examples of the topic that's going to be covered in this unit. And then maybe I'll take a look at, yeah, I'll take a look at number 4 after 2 then, I think. Those seem like reasonable ones to do. This is Math 3102A. This is Unit 2. Page 90, question 1A. Determine the 50th percentile for each data set. Hint, the 50th percentile is the median. Well, there you go. Don't have to do 4, only 1, 2, 3, and 5. Excellent. Great. So that's why I'll definitely focus on 4. Good. It's good to know. Yeah, 4 is a good question. So I will definitely do that one then. So for part A, the 50th percentile is the median. Well, how do we find the median? First up, we just got to put the numbers in order, right? We always got to put the numbers in order first. So we've got a 0. What else have we got? We got a 0, 2 3s, a 6, a 9, let's see, 110, yep, a 10 and an 11, 10 and an 11, a 12, and then 3 15s. Now, is that all of them? Well, let's just make perfectly sure that I did take all of them. Get my cursor to come back up. There we go. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, crap. I accidentally doubled up on something that I wasn't supposed to, did I? What did I mess up on here? Oh, is there no 11? No, there's not. Okay, sure. Well, there we go. It's good evidence for why you need to check, right? You always got to check these things. Yep, no 11. Thank you. It's a good catch. Hello, hello, Brittany. Good morning. Or afternoon. Or evening, depending on where you are, I suppose. Okay, so determine the 50th percentile for this data set. Well, the 50th percentile is indeed just the median, right? So how do we find the median? Well, now this part the book doesn't show you, because I've looked down through the notes and I've seen what they've told you. But this is super easy, just the n plus 1 over 2, where n is the number of numbers. And this tells us which number in order is going to be the median. So here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to have 11 over 2, or 5.5. Okay? So when it's a 0.5, this tells us now that we have to, we're going to have to take the average of two numbers on here, or the mean of 2. 1, 2, 3, 4, 5. We see the fifth number is 9, and the sixth number is 10. So it's going to be right here in the middle of these guys. Right? So our median is going to be 9 plus 10 over 2, which is, of course, 19 over 2, which is going to be then 9.5. Right? So we know that 9.5 is there right in the middle. So 9.5 is the median or the 50th percentile. Right? I'm also going to, let's see, I'll do two for question 1, and then I'll carry on with those same ones afterwards then, excuse me. So I'm going to go with 1A, and I'll also do 1D, I think. Hold on just a quick second. Okay, so for 1D then, I'm going to put these guys in order. We're going to have, let's see, 56, 61, 64, 68, 71, 73, and 88. Now again, I'm going to count to make sure that I have the same number of values here that I should have. Right, so that's going to be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There we go. Okay, good. Good. So now the median for this one is going to be n plus 1 over 2, which is going to be 8 over 2, which is going to be the fourth one. And we see that the fourth one in order is going to be, so the median equals 68. and that is the 50th percentile. Okay? Yeah, it's fairly straightforward. Hey, so now I'm going to go ahead and do the second part. So I'm going to go questions 2 and 3, right? So this will be 2 for A. This will be determine the 25th percentile. So how do we determine the 25th percentile? So 25th percentile is the median of the lower half of the set. All numbers below median. Right. So all we got to do to find the 25th percentile is we're just doing the median again. Just we're doing it with a smaller set now, right? So now we're going to look at all numbers that are below the median. Now our median is 9.5, so it's right here in the center. Right, so the numbers below the median are going to be 0, 3, 3, 6, and 9. Right, those are all the numbers in this set that are below the median. So now we're going to take we're going to act like we're just taking the median of these guys, right? It's 5 numbers, so we're going to do 5 plus 1 is 6. 6 divided by 2 is 3. So we're going to have the third number. So the 25th percentile is just going to be 3 because it's the middle one. It was the middle one. That's right. So then, for question D, for 2D, for example, so the 25th percentile here now, we're still just going to take all the numbers lower than the median. So we've got 56, 61, and 64. So the 25th percentile equals 61, as we see it right there. Right? That's fairly straightforward. So then for 3A, so the 75th, unsurprisingly now, if the 25th percentile is the median of the lower half, 75th percentile, guess what? Is the median of the upper half of the set. Right? All the numbers greater than the median. So here now it's going to be 10, 12, 15, 15, and 15. So we're going to have 15, just the middle one of those. Right? So the 75th percentile is 15. All right. So I think we're seeing how to do this now. It's pretty good stuff. So then for 3D, I'll show you down here as well. So now we're going to have just the top half of these numbers. So it's going to be 71, 73, and 88. So the 75th percentile is the median of those, which is 73. So the 75th percentile equals 73. There we go. These values are also used to make what we call box and whisker plots. Now, for whatever reason, the program that we do here doesn't include box and whisker plots, and I find that a bit strange. When I taught in the UK, we did box and whisker plots quite a bit. I remember doing them myself in high school, and I definitely did them in MUN as well, in university, in the stats courses that I've done. But a box and whisker plot looks sort of like this. Right? So it's a useful sort of graphical representation for determining the spread of the numbers. Right? So this is what we call a box and whisker plot. Right? So a box and whisker plot has separate sections basically, whereas this here, this is the median. So basically we assign numbers to this, right? That's the median. This is the upper quartile. This is the lower quartile. This is the min value. And this is the max value. Right? And we sort of put those over, like overlay them on top of the number line. And then that is a very good representation of how the data is distributed, right? So this is a super useful thing to know. There aren't any specific activities in our current course on this, but it is directly derived from this topic, right? But it's a representation of how far the numbers are spread apart. And it shows us a graphical representation, say, of how close the numbers are together. It's interesting, say, when we have this one here, say, for example, in this one, if we drew a box and whisker plot, we would see that the upper quartile and the max value are actually the same, right? Very odd situation for that to be the case, but it's only the case because this 15 was doubled up or tripled up on there, right? There were so many 15s. But I'm going to carry on now then to, let's see. Esther needed to do number 5. Yeah, okay. I'm not going to do number 5, but I will do number 4. Number 4 will show you how to do number 5 because there is a wrinkle in number 5 that is something that you haven't seen before, and that is going to be 5B and C. But 5B and C are the same operation as 4B. So I'm going to do 4A and B instead. So this is going to be math. Let me get this Revel off of here. So this is math 3102A unit 2. This is page 90, question number 4A. What value is at the 50th percentile, the 25th, and the 75th? Okay, so let's do 50th first. 50th percentile. Well, which of the numbers is that going to be? So that's going to be n plus 1 over 2, which is going to be, how many data points are in set 1? Oh, they don't tell us. Well, that's annoying. All right, then let's count. Let's count over here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 33. So it's going to be 33 plus 1 over 2, which is going to be 34 over 2, which is going to be 17. So the 17th number in order is going to be the one that we're looking for. And we've already got this in order, although it's worth noting that they're actually going in reverse order. This is the high numbers and this is the low numbers here. Not relevant for this first part, but will be relevant for the 25th and the 75th percentiles. So the 17th number in is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So the 50th percentile is equal to 29. Okay, so now the 25th percentile is going to be the median of the lower half of the numbers, right? So how about we just count and see how many of the lower half of the numbers we have? This is good content, right? This is a counting stream, NL Mathman's counting stream. I am aiming to dethrone Count Von Count as the world's #1 counting streamer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. Well, how could we have guessed that? Well, of course, we knew it was going to be 16. The 17th value was our median, right? So there's 16 below it. It only makes sense. So it's going to be there's 16 numbers plus 1 over 2. It's going to be 17 over 2, which is going to be 8.5, or the 8.5th number, right? So now we go and we count again over here. 1, 2, 3, 4, 5, 6, 7, 8. Number 8 is 20. Number 9 is 22. So here it's going to be 20 plus 22 over 2, which is going to be 42 over 2, which is going to be 21. So the 25th percentile equals 21. Okay? So then we're going to go on to the 75th percentile. Right? And again, we've got 17 numbers below it. Right? So there's 34 numbers, so it's still going to be the, say if we go down from the top, it's going to be the 8.5th number again, right? 8.5th number down. But I'll do it again here just so you see. So 8.5 down from the top. So let's go count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, geez, what am I doing? 1, 2, 3, 4, 5, 6, 7, 8. 8 is, so it's going to be 35 and 36. So it's going to be 35 plus 36 over 2, which is going to work out to be 35.5. So the 75th percentile equals 35.5. Okay, so that is how you do 4A. Again, that's very similar to the ones in question 1. That's where I've left out a few of the ones from question 1 as you have seen. Those will be good ones for you to practice for your notes. Right? Now for 4B, 4B is really important because this one is very similar to the question number 5. What percentile rank is a value of 11, 32, or a 41? Ah, how do we find that? Well, percentile rank shows the position of a value in a group of numbers, right? So it's super important to know that percentile rank shows the position of a value in a group of numbers. So for number 11, if we count from the bottom up, as we're doing over here, right? It's 1, 2, 3, 4. So that's the 4th number. So 11 is the 4th smallest number, right? So its percentile is 4 out of 33 because it's the 4th smallest out of 33 total numbers. So then I break out my good old pal over here, do my 4 over 33, hit enter. That's going to be 12%, or we can call this 12th percentile. Right? So percentile is always a way of comparing numbers within sets of numbers, for example, right? If you hear like that someone, you know, they might say, "Oh, I wrote the 75th percentile or the 80th percentile." Say, like on my test, I was in the 80th percentile of students. That doesn't mean that you got an 80. Doesn't mean you didn't necessarily have gotten anywhere near an 80. It could be a really hard test, and the 80th percentile could be like 60 or 65. Could be a really easy test, and the 80th percentile might be 95. right? It doesn't mean anything about what the actual grade or mark is or what the actual value is. What it means is it's higher than 80% of the other scores, lower than 20% of the other scores, right? So sort of the same deal here. So 32 is which number in order is 32? Well, how many down from the top is it? Right, we got my cursor over here. Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 down, so it should be 21 up, right? 1, 2, 3, 7, 7. That's 12, 17, 18, 19, 20, 21, 22. Yeah. Okay. 22nd one up, yeah, because you would have one on, yeah. So is the 22nd number. So it's 22 out of 33. That's going to equal 67%. Hey, look at that. My God, how do I know that one? That's a super tough one. Super tough to do in your head, chat. That's a hard one. Or 67th percentile. Right? So in this data set, the number 32 happens to be the 67th percentile. Up here, 11 being the 12th percentile, it was just total blind chance that these two were a similar value. This one here, 32 and 67, not similar in the slightest, right? But it doesn't matter because all it's showing is the sort of the place in line that it takes, right? And then number 41. So 41 appears to me to be, well, there's three numbers greater than 41, so it should be the 30th. So 41 is the 30th number. So its percentile is 30 out of 33, which is going to equal 10 over 11. 30 out of 33, which is going to equal 91. So it's the 91st percentile. Right? So again, for percentile rank, this is super important. Percentile rank shows the position of a value in a group of values. Right? So that's super important here to know. That's really important now for, say, 5B and C would have the same deal. If you're dealing with a percentile for a score that's not in the list, which, okay, you're not number 5. All right. So later on, you might end up dealing with the situation where the number that you're trying to find the percentile for is not in the list. What you do then is just kind of add it to the list, right? Like say they were asking me here for, as an aside, so imagine if you need a percentile for a number not in the list, add it to the list. Right? So if you need a percentile for a number that's not in the list, which you may see, you have to add it to the list. Like say here, I wanted to find 14. So 14 would be the 1, 2, 3, 4 would be the fifth number. So its percentile would be 5 out of 34 now, not out of 33, 5 out of 34, which would equal 15 percentile. Right? So that is important to know as well, that if you have a situation where you're asked to find the percentile value for a number that is not in your set, you have to add it to the set. And it also means that you change then the denominator. Right? So Esther, I think that should cover that pretty well. Right? Because now you're equipped to take on, say, question number 5, because I've covered all the different stuff that'll be needed to be done there. and then all the different ones for questions 1, 2, and 3. Okay? So I hope that helps out for those topics. Right? I will, yeah, and if you got any other questions that you want me to go over, you can just let me know. Now, I will try to remind people that you need to, if you want me to do something on stream, you have to let me know before the stream starts. And also, Brittany, if you're still watching the stream, it seems it seems maybe just popped in to stick your head in to say hello and then left. Um, you do know, like I say this every single stream, it doesn't count for your attendance to pop into my stream. Okay, you do have to send an email to myself or Jennifer or some other form of communication, right? But where anybody can make an account on Twitch and anybody can call it whatever they want, any sort of random nonsense, we're not going to be using Twitch as an official contact source for attendance. Maybe that is then shooting myself in the foot because it appears that people just don't watch. But you know, such is the life of a Twitch streamer. Just sort of ramble on. Hopefully entertain yourself. That's the main person, right? Like most Twitch streamers entertain themselves by playing a video game they like. Me, I entertain myself by you know I don't entertain myself. That's kind of the point. No, I entertain myself by keeping you all educated, right? Anyway, so now I'm going to go on to Math 3101B review number 1. Math 3101B review number 1. I'm going to do some, let's see, here we go. Simplifying and stating non-permissible values. Let's do a few more of these ones. Yeah, let's do I and K for sure. Let's do G as well. G, I, and K maybe? Gink? Yeah. Yeah, let's at least do those ones. So now I'm going to zoom in on G over here. There we go. Yeah. Six minus x over x cubed minus 36x minus 1 over x minus 6. Okay, now we notice that we've got the same term up here as we do down here. What can we do about that? Can we go ahead and cancel? Well, no, we can't. We can't cancel because this operation in the middle, this is a minus, right? If this operation was a times, was multiply, then we could. We could go ahead and cancel this with this, but it's not. The thing is, this is a subtract, which makes these two things different terms. What we're going to have to do is multiply it by something so that we can start getting these to have the same numerator and denominator. Now I could go ahead and just sort of brute force this and multiply this one by x minus 6 over x minus 6 and multiply this one by x cubed minus 36x over x cubed minus 36x. I could do that, but I'm not gonna. Because what I'm going to do first is I'm going to simplify this down as much as I can and then see if anything becomes any easier out of it. So I'm going to call this now 6 minus x over, well, I know I can factor an x out of both those. So let's call that x outside of x squared minus 36. But now I can notice something, right? Because now over here, we've got what we call the difference of two squares. This is x squared, this is 6 squared, and there it is a difference because they're subtracted. So now what I can do is I know that I can factor this one really quickly. We can now call this 6 minus x over x, x minus 6, x plus 6. minus 1 over x minus 6, right? Now I couldn't have, yeah, you're right to point out, if you notice, that I couldn't go ahead and just cancel those ones directly because the signs are different, but it would sort of cancel to leave a -1 behind, which is something that I can do here now. I can indeed cancel these ones to leave a -1 behind, but I'm not gonna. I'm not gonna right away. And you know why, Twitch chat? Because this is the same over here as it is over here, right? So now I can see that if I want to get the denominators to be the same in both cases, I actually don't need to multiply anything by this x minus 6 because it's already present in both places. I just need to take these two terms, the x and the x plus 6, and multiply them by this one over here. So I'm going to go ahead and show you what I mean. 6 minus x over x, x minus 6, x plus 6, minus 1 times x, x plus 6 over x, x minus 6, and x plus 6. There, get those s's, those good whistly s's. So now what I can do is I can just go ahead and get rid of all these denominators because the denominator is the same here, denominator is the same here. I can just go ahead and strike them all out. So we're left with 6 minus x minus, and now what's all this multiplied together going to be? Minus x squared plus 6x, right? So can keep going on here. So we've got a negative x squared, right? Because this one's going to be negative. Excuse me. Minus 7x plus 6. Or if I want to, I don't much like having the negative here on this first one, right? So I'm just going to go ahead and I can sort of flip all the signs, right? Because let me see what have we been asked to do in this question? We've just been asked to simplify, right? Simplify and state the NPVs. Okay, okay. So never mind then. Never mind. I don't need to carry on. Don't need to solve. If I had this equal to 0, like if I was told at the start that this equal to 0 or something like that, then I could go ahead and find this. So I can find the roots to this one, no problem. But we're not asked to find the roots to it. So this is already simplified. All right, but now what are our NPVs? Well, we know NPVs are any situation where the denominator is equal to 0, right? So the NPVs here, what we have is x minus 6 cannot equal 0, which means x cannot equal 6. Okay, that's pretty straightforward. And we've got this one over here as well. So x cubed minus 36x cannot equal 0, which means I'm going to keep factoring it like I have done over here, and I'm just going to write it out again so you see. X outside of x squared minus 36 can't equal 0, which means x minus 6, and x plus 6 can't equal 0. So none of these situations can equal 0. X can't equal, so what we know then is from this one, we know that x can't equal 0. For this one, we know that x minus 6 can't equal 0. So x can't equal positive 6, but we knew that one already. And from this one here now, we know that x plus 6 can't equal 0. So x can't equal negative 6. So our NPVs, x does not equal 0, 6, or negative 6. Right? So, and remember, we use the original version. We always use the original version to find our NPVs, because if we were just given this guy down here, this has no NPVs. Right? This is just a normal quadratic with nothing fancy. This could take a 6, no problem. This could take a negative 6, a 0, you name it, right? But the thing is, the way it was originally written, these values were non-permissible. Even though it simplifies down into one where the values are permissible, we still go with this form to determine these. So let me go ahead and, yeah, I'm going to do at least, actually, let me see, does this one here, oh, no, I'll do this one. I'll do H. H is a good one. Okay. So for H here then, this is a nice one. X over X plus 2 times X plus 2 over 3X. Now, one reason this is a good one is because this is that very first thing I was yammering about in this last question, where I said that I could have, if this was a multiply, I could have canceled these ones. I would have actually been left with a -1 here, but you know. Here, yeah, we do have multiply. Look at that. Which means we can cancel. I'm going to put these in brackets just so it's clear what I'm doing. Uh, Can the past streams be saved, or do they only last so long? Yes, the past streams are, I believe all my past streams are still up, the real Albert Einstein, because I've been, they last for 60 days. If I, let me see, are they still there? Oh no, no, day one is down. Is day one not there anymore? Oh, oh, I'm gonna have to go talk to, oh, what am I gonna have to do? How am I gonna, oh boy, oh boy, oh boy, more stuff going wrong. No, I attached my Amazon Prime to my account, so they're supposed to be up for 60 days, not 14. But it appears that Twitch has started taking them down. Yeah. Oh boy, oh boy. You never can win. I gotta like, boy, oh boy. Yeah, I've got them saved myself though at least, so I can go ahead and I guess I'm gonna have to start using other websites other than Twitch because Twitch is not doing because with Amazon Prime you're supposed to get 60 days of the videos being saved, 60 days, and they're down. They're started taking them down after 14. Boy, oh boy, oh boy, you cannot find good help on the internet. Let me tell you, we'll just anyway, no, I've still got the videos saved. I guess I'll upload them to YouTube. I'm gonna have to go to YouTube instead of Twitch because they're not. Twitch is not cooperating with what they said they were gonna do. I'll have to check it again after stream, I suppose. So here now we've got an x plus 2 on the top and an x plus 2 on the bottom. So I'm going to go ahead and I can cancel these guys just out there like that, right? And I can cancel this x with this x. So now we're just going to be left with 1 over 3. That's it. This one simplifies down. 60 would be better, but 14 should be all right. Well, 14 is okay, but like I'm paying money, like actual real world money to get the 60 days, and they're only giving me the 14. Like I'm not even making money off the stream. I am paying money for this stream, and they're not delivering. Anyway, I'll deal with that there now in a bit, I suppose. So now the NPVs for this one, it's worth, again, right, 1 over 3. 1 over 3 is just 1 over 3 all the time. There's no NPVs for a 1 over 3, right? But in this situation, we do have NPVs from these first two ones. So we know that x plus 2 does not equal 0, which means x does not equal -2, right? And now over here, we have 3x cannot equal 0, which means x cannot equal 0. So even though this simplifies down to being just 1 over 3 with nothing else going on in it, we do know that it has to be there have to be NPVs because the original form had x plus 2 on the bottom and 3x on the bottom, which means x is not going to equal -2, x is not going to equal 0. So I'm going to do at least 2 more of these ones, and then I'm going to go have a fun afternoon of trying to troubleshoot both Rogers and Twitch because, it'd really be a crime if something went right, wouldn't it? Like it would just why would you want something to go right, right? It just doesn't feel like you earned something unless you've got to kick and scream and scratch and moan and just struggle for all the stuff that you're doing. So math 3101A, 3101B, no 3101B. Math 3101B. Oh, look at that. Drop some more frames right on cue. Right on cue. Thanks, Rogers. Review number 1. Okay. So this is now going to be, I'm just going to call it I. I can't remember which question it was. I of. So that's going to be 3y squared over 4x divided by y over 8. What the heck does this divided by y over 8 mean? Oh, Twitch, I'm also, my chair is also in, oh, oh my God. How many things can go wrong today? We'll find out, I guess. How long is the day? I guess is more the question. When we have a division sign like this, we don't actually write division like this. And if you recall back to some of the older courses that you've done, oh, day 1 is still there on yours. Well, I'll go. I'll check on what I can see on the video. I couldn't see it there. Um, I see a day 1. I see a clip. I see a clip from Emily for day 1, but I am not seeing the. I'm not seeing the video for day 1. Oh, there it is. No, okay. No, I can see it in through there. All right. Okay, Bert. Yeah, that might be. Maybe it is. Maybe it is still there. Maybe that was just. Maybe that's just me. Okay, let's. It's probably it's just me being too negative. That's all. It'll be all right. Okay, so we're gonna do 3y squared over 4x divided by y over 8. It's gonna be 3y squared over 4x multiplied by 8 over y. Right? Because what we do in order to divide by a fraction, we take the reciprocal of it and then we multiply. Right? Now once we flip this like so, now we can start canceling some stuff out of here. Right? So we get the 2 out of the corner. That can cancel with this y down here. This 8 and this 4, that can become a 2. So what we're left with now is 6y over x. And that is that's as simple as this guy is going to get. Excuse me. Then if we're looking for the NPVs, or the non-permissible values, those are going to be, again, based on the original, right? So the NPVs in the original, we know that 4x can't equal 0, which means x can't equal 0. But we also have another thing going on here in the original that's a little bit different, right? For purposes of NPVs, we also know that y can't equal 0. Well, why can't y equal 0? Y's on the top, right? That looks like a numerator. If it's in the numerator, you should be fine for it to be 0, right? Well, the problem here is that we're dividing. We are dividing by y over 8. So if y over 8, if the y on top is a 0, then this whole term becomes 0, which means we are indeed dividing by 0 because of this division sign here. It does throw you for a loop sometimes in algebra because you very, very rarely see a division sign written out like that. Usually it's just written as multiply, and you multiply by the reciprocal, right? So here, you could realistically treat this one as the original form if you want, because all I've done is flip this one. But we still do kind of go with the original, but the thing is we can't divide by 0, right? So we also know that y cannot equal 0 in this question. But yes, I will be getting the videos put up so that they will stay up in perpetuity for sure. I've got them. I'm saving them all locally for now. It's quite a lot of video, but it's all right. My hard drive wasn't being used for anything else, so I will make sure to save all these ones to archive my complaining about Rogers for the ages. Just put that in a time capsule and seal it. Right? 5 over x minus 2, subtract x plus 1 over 4x minus 8. Okay, so now again, this one is still a subtract, right? So we can't go ahead and start canceling across like we could say in H. So I am going to simplify these down as much as I can. Now, unfortunately, we don't have any of the fancy situations like we did before, but I can factor something out of this one. So we have 5 over x minus 2, subtract x plus 1 over 4 outside of x minus 2. Okay? So now we see that the denominator over here is the same as this denominator, just with a 4 multiplied by it. So, like we went over before, I can multiply a fraction by anything I want as long as the top and the bottom of that thing are the same. So we're going to have 4 over 4 multiplied by 5 over x minus 2 down here, minus x plus 1 over 4 outside of x minus 2. Okay? So now I go ahead and I can multiply these. So I'll have 20 over 4 x minus 2 minus x plus 1 over 4 x minus 2. And like we've seen before, what we can do now is just go ahead and cancel these guys. Just like that. Get them out of here. So we have 20 subtract x plus 1. Now I put this one in a bracket here just to remind us that the subtract goes on both, right? So we have 20 minus x minus 1, or rather, now just 19 subtract x. And that is as simplified as this is going to get. And again, just to keep beating that same horse, NPVs are from the original. So the NPVs, we know that x minus 2 cannot equal 0. So x cannot equal 2. We know that 4x minus 8 cannot equal 0. So x cannot equal 4x cannot equal 8. So x can't equal 2. So that is the only NPV that we have then for these questions, is that x does not equal 2. Okay. Well, that is, yeah, those are the topics that I wanted to get to today. Excuse me. I think in my email, I see one other question. Yeah, in general, please do include your page number. If you have a question for me on stream that you want me to go answer while we're live, I'm totally able to do that, and I'm glad to hear from people with questions to do on stream. But please do include the page number. Right? This is all the books. Lesson 3 is not really enough to say, right? Because there's plenty of lesson 3s in plenty of different units and chapters and all this kind of stuff, right? And just saying, oh, it's the chapter that I'm currently working on. Well, I've got 20 students, right? Like, I don't necessarily have the chapter memorized that everybody is working on right this second. Uh, 3, and 3 number 2a, 5 over. Okay, yeah. So how about I can do one of these ones on stream, I think. Sure. So this will be some decent stuff to close off with for today, and then this can be for Carly. So in case Carly does get to see these notes, then this will be some. Let's see. This is going to be Math 2014, I think. So let me just switch on back to having something nicer up there in the corner. There we go. Flurry and Smokey can keep us company. So order from least to greatest, right? 74%, 0.92, 4 over 5, and 81%. My recommendation here is to get them all to be the same form. So get all values to be the same form, right? So here now I'm going to convert all of them to be decimals, I think, right? So for question 1a, 74% equals 0.74. We also have 81% equals 0.81, pretty easy. Then we have 0.92. We have 4 over 5. Well, how do we get 4 over 5 to be a decimal? Well, all you got to do, because for this course and all the ones following, you can indeed use a calculator. So I'm just going to go 4 over 5 on here, get a 0.8, 0.8. There we go. Right? So now we know that in order, this is going to be 0.74, 0.80, 0.81, and 0.92. Or the way the question asks you to write it is to go and write them back in the original form that you had. So this is 74%, this is 4 over 5, this is 81%, and this is 0.92. That's all you got to do. That's all you got to do for 1A, right? Now, Carly, you might recall that I advised you to leave this page until last in your current unit, even though this page is actually, they tell you to do it first, and a rare misstep in the Prism Math book, in my opinion, is that they tell you to do this one super early on, right? Kind of before you've practiced all these different ones. But now that you've practiced them all, I'm sure you are able to approach these a lot more easily than you would have first. And now 12 over 25. What does 12 over 25 equal? Well, there's a whole bunch of different ways that we could figure it out. But I'm just going to go 12 over 25, just like that. Click. There we go. 0.48. So now we know that the numbers are 0.4, 0.45, 0.48, and 0.50. And know that 0.4 is the same as 0.40, right? After a decimal, the number of zeros that follow doesn't actually matter. All right, so that's 1A and B right there. And now we see those are the answers. And you asked specifically about 2A, so I'm going to go ahead and do 2A and B as well. And then that should be good for today. Let me just do some paper crafts for a quick second here. So I can do this stuff on stream while also not necessarily showing everybody every result, every answer to these pages, right? Especially for the students doing Prism Math, it will be, I do kind of want a heads up before I answer questions from these ones so that I can maybe make up something where we don't go and see the solutions. But either way. So 44%, 44% equals 0.44. This one I know. I have 0.39. Now what are the other ones? 2 over 5. Well, I found before that 4 over 5 was 0.8. I know that 2 over 5 is going to be 0.4. But again, right, we could do it in the calculator. Oh, that's 2 over 4 I did. 2 over 5, pretend I did the right one. There we go, 0.4, easy. Right, and now 5 over 12, we just do 5 over 12 in the calculator, and we get that. 5 over 12 equals 0.41666 and so on, or I'm just going to call it 0.42 just to keep it, just to round it to the same number of decimal places. And this symbol here means approximately equal to. So now in order, it's going to be 0.39, and then 0.40, then 0.42, then 0.44. Or it's going to be 0.39, then 2 over 5, then 5 over 12, then 44%. Right? And now I'm going to go with 2b. Right? 35% is going to be 0.35. We have 0.3. We have 3.8% is going to be 0.038. It's important to know, right? We always move the decimal place twice, even if we had to put in another 0 in order to give us enough digits to get there. And now this last one is 1 over 3. Well, I know 1 over 3 is 0.3333 and repeating, but I'm going to say that's approximately 0.33. Right? It's not exact, but it's close enough for our purposes here. So now we're going to put these guys in order. So the smallest one is 0.038 because it's got an extra 0 on front, which means this is 3/100ths, right? Whereas the 3 here, that's 3/10ths. 3/10ths is like 30. 3/100th is like 3, right? You can think of it in terms of cents, right? Like this would be 30 cents. This would be about 4 cents. So obviously 4 cents is less than 30, right? So our first one is this, then it's 0.30, then it's 0.33, then it's 0.35. Or in other words, it's 3.8% first, then 0.3, then it's 1 over 3, and then it's 35%. We go down, and there it is, right? See that those are the answers there. So, Carly, I hope that was useful for what you were doing. Yeah, so we've made it. We made it to the end of another stream, right? Thanks very much for being here with me and keeping me company. Yeah, sorry about the bit of the rockiness. I am more than a little bit frustrated with Rogers. I have I mean I've called them like 5 times in the past 6 days or something, and every time they swear that oh, there's an issue in the area, we've got it fixed, and well, there's an issue in the area, sure, but it ain't fixed. It ain't fixed. It ain't. Anyway, don't want to keep rambling about ISP problems. Everybody's got those. Anyway, folks, yeah, thanks for being here with me. Yeah, I hope you're staying safe out there and keeping positive. A little bit hypocritical of me, I suppose, to have been so negative today. But I do have this. Look, I've got a little sip of my root beer left. That's something to help make me feel positive. And I got these little pictures of doggies so I can virtually pet. Look at that. Only 700 kilometers, several hundred kilometers away from them. That's all. So I can just do this. There we go. That's nice. Pet little buddy. All right. Thanks for being here with me. Have a great day. And yeah, I hope to see you again tomorrow.